Hey guys, welcome to 6.8. So today we are going to be graphing secant and cosecant graphs. They're actually not that bad at all. So once you kind of see what's going on, you're going to get the hang of it. To remind you, cosecant is the reciprocal of sine, right? So those two kind of go hand in hand. And then secant is the reciprocal of cosine. All right. So similar to how we graphed sine and cosine last week for the first time ever using a chart, we're going to do the same thing today, just so you guys can kind of discover it first, and then I'll kind of show you like a quick hand. All right. So for sine, I'm going to do my sine graphs in like this goldish color, and then I'll do my cosecant in like purple. So for sine, just to remind you, without using a table, just because it might be easier to do this first and then the table. So for the parent, we always start on the midline, which is the x-axis for the parent, and the y-axis right there. All parent sines have a period of 2 pi, so that means it ends there. Then we do our halfway method, and then halfway to find the quarter points. And then we go up however much the amplitude is, which on the parent, it is 1 unit. And then we go down 1 unit. And that is 1 full period for a sine graph, right? And then we can do it on the left as well. I'm gonna go ahead and make that happen. Cool, so there's our sine graph. So as you guys can see, the sine of 0 is just 0. We'll come back to these. Pi over 2 is 1. Pi is 0. 3 pi over 2 is -1, and 2 pi is 0. So for these, I'm just looking at my graph because it's easier. How did we find these in the first place? You guys either used your calculator and you put it into radian mode, right? Or we looked at our unit circle and how do we find sine of, let's do pi over 2. Well, sine is the y value on the unit circle. So if we go to pi over 2, what is the y value of that coordinate point? 1. And that's why sine equals 1. Same thing if I have it in radian mode, only this will only work if it's in radian mode. And we do sine, that's log, sine of pi button over 2, we get +1, okay? So your choice how you guys want to fill this out. We may as well get used to our unit circle. So at pi over 6, we're looking for the y value. So at pi over 6, our sine is 1/2. At pi over 4, it is √2 over 2. And at pi over 3, our y value is √3 over 2. So obviously, if I graph these, that's pi over 4, that's pi over 6, which is at 1/2. That's right about there. Pi over 4 is √2 over 2, which is approximately 0.7, which is right pretty much where my graph is. And then at pi over 3, it's √3 over 2, which is approximately 0.9, like it's almost at 1. That's why it's up here so high. Okay, so that's all those points. So now let's think about this. How are we going to find cosecant? So again, we know that cosecant's the reciprocal of sine. So literally all we have to do is, as long as these are fractions, flip it, and that's the reciprocal. So for example, 1/2 is already a fraction. So if we flip that, we get 2 over 1, which is just 2. If I flip that, I get 2 over √2. And because we're not leaving this as our answer, we're technically going to go find our decimal. You guys don't need to multiply top and bottom by root 2. Same thing here, flip it, and we get 2 over root 3. So we'll find those decimals in just a moment, but let's focus on this guy. How do you guys make any whole number into a fraction? You put it over 1, right? 0 divided by 1 is just 0. So if I take the reciprocal of that, I get 1 over 0. And what does 1 over 0 equal? Undefined, right? I can't calculate that. Okay. 1 over 1, what's the reciprocal of that? Same thing, 1 over 1, or just 1. I have another 0 over 1, so that means that 1 over 0 is undefined again. Negative 1 over 1 is just 1 over negative 1, which is the same thing. And then I have another 0 over 1, which is undefined. All right, so let's graph what we can graph, okay? So at x equals 0, it's undefined. I don't know if you guys have an idea about what that looks like, but let's think on that just for a minute. Try and ponder that, but let's move on to the points that we actually do have. So at pi over 6, we're up 2. So pi over 6 is 2 units over, and we're up 2. Okay. Pi over 4 and root 2 over 2 is about, no, it's 2 over root 2, sorry. 2 over root 2. It's about 1.4. Okay, and then 2 over root 3 is about 1.2. Okay, so at pi over 4, which is 3 boxes over, we are up 1, almost 1.5. And about there. And then at pi over 3, which is 4 boxes over, we are at 1.2, so just above the 1. And then at pi over 2, we're at 1. So that point's actually the same. Interesting. Okay. At pi, we're undefined. Not sure about that yet. At 3 pi over 2, we're at negative 1, which is the same point. And then at 2 pi, we're at undefined. So what do you guys think undefined means? Let's talk about it in terms of a slope. Do you guys remember if we have a slope that's undefined, what does that line look like? It's a vertical line. Vertical lines have slopes that are undefined because you go up 1, 2, 3, 4, 5, but you go left and right 0. And what's anything divided by 0? Undefined. So that's why it's actually a vertical line. Specifically, it's an asymptote. So we're looking back at asymptotes again. Okay, so we will not have any points here because they are all undefined in our trig for cosecant. So at 0, it's undefined, at pi, it's undefined, and at 2 pi, it's undefined. So notice how for the parent graph, it's happening at every single pi value. So at 0 pi, 1 pi, 2 pi, okay? So basically, cosecant is undefined wherever sine hits the midline, okay? And let's kind of see if I connect, because these were 4 points, right? So if I connect those 4 points, and then what did we use as asymptotes in the past? Guidelines, right? So if we kind of use this as a guideline, where is this going? Like that. What does that kind of look like to you? Either an exponential or half of a parabola. This is half of a parabola. So if you guys were to continue to plug in numbers, which you can if you'd like to, you would see that points extend this way to form a parabola. So notice how the vertex of the parabola is on the peak. And then remember how at 3 pi over 2, We were at -1 for sine, and we're also at -1 for cosecant. So if the vertex of the parabola was the peak here, what do you think is happening down here? This is also the vertex of a parabola. Do you think it's going to face the same way? Nope, this one actually faces down. So you guys don't need to find specific points on the parabola. Just make your peaks and your valleys your vertex, and then approach the asymptote. So the peaks will always be right side up parabolas, and the valleys of the sine graph will always be upside down. This is considered one full period for cosecant. So notice how there's two parabolas in one full period, not one parabola, right? Two parabolas, one full period. All right, so that's what cosecant looks like. Not bad, right? So to do this the kind of like shorthand way, for me personally, I like to draw my sine graph first. Then I will take all of my points that lie on the midlines and I make those asymptotes. Then my peaks and my valleys count as vertices to my parabolas, and then I just draw parabolas. Boom, boom. That's it. So that's how you can shorthand draw it. Not too bad, right? So as long as you guys are feeling solid about sine and cosine graphs, literally the only difference or forward steps, additional steps for secant and cosecant will be to draw the asymptotes. I do want to see those, and the parabolas that hit those points. So some people don't even draw the sine or the cosine. They just draw like these 2 points, maybe even these. They don't actually like connect it. I like to connect it just to give myself more practice and guidance. Okay. So you guys know how sine and cosine look exactly alike. They're just shifts of one another. Like here, that's a cosine graph, right? From here to here, that's a cosine graph. So if this is what cosecant looks like, secant actually looks the same, but instead of having a sine graph as its original parent, it has a cosine graph as its original parent, because secant is the inverse, or sorry, not inverse, reciprocal of cosine. All right. So we can create a table if we want to, but let's try and do this shorthand so that you guys can not worry about tables. So I'm going to draw my parent cosine first. So it starts 1 unit above. The parent period is 2 pi, also ends 1 unit above. And we count halfway and down 1, and then halfway and on the midline. So here is my cosine graph, like so. Then same thing for just like we did up here. Wherever you guys see points on the midline, those are going to be your asymptotes. Because what's the reciprocal of 0? Undefined. So it'll be an asymptote. Okay. And then the valleys will be the vertice, and it'll be upside down, like so. And then the peaks will be the vertices of our right side up parabola. So in one full period of cosine, in one full period of sine, you see 2 full parabolas, right? In one full period of cosine, you technically also see 2 full parabolas. There's one full one, and then 2 halves that make a whole. So this is one full period of a secant graph. And then if we would have extended this, we would have seen that this actually does continue. That's it. That's it. Not too bad, right? So I want to see if you guys have the hang of this, and then we are literally done. Yes. So let's see. You guys want to practice a couple. So I'm gonna have you guys try this one. Okay, so go ahead and pause the video. And I really want you to try this on your own just to see if you have the hang of it. And then we'll come back, okay? I'm just gonna put up the key. I'm not gonna walk us through it. Well, maybe I'll walk us through this one. Okay, so cosecant is the reciprocal of sine. That's really important that you have to remember which one to start with, okay? So for my sine graph, our midline is 1 because of that plus 1. So what I'm graphing right now is literally the same thing. I'm just changing the cosecant to sine. So this is 2, and then instead of cosecant sine, x plus 1. So I'm graphing that first, then I'm going to draw my asymptotes and parabolas. So up 1, my period is 2 pi, and my amplitude is 1. No, 2. Right, and then what makes this cosecant graph is that we have asymptotes on the points that are on the midline. And then I just draw parabolas that approach the asymptotes and have vertices on the peaks and the valleys. That's it. It's the quickest additional step for you guys to add to what you already are so good at. That's it. All right. So I got 3 more for you guys to try if you'd like. I'm just going to pop up the answers. That is it. And then we'll move on to homework. So here's your next one if you want to try this one out. Go ahead and pause first, because then I'm going to pop up the answer key. You guys, I'm sorry. I always forget to change this one. And I don't have my notes on me to remind me. We actually skipped this one. You will never have a period that is this ugly. So don't worry about that one. So never mind. You have 2 to do. So go ahead and do number 3, and then we'll do number 4. So we'll try number 3 first, and I'll pop back up with the answer. All right, so here is our answer. First thing I hope that you didn't forget about is that this is a secant graph for number 3, so it derives from reciprocal of cosine, so that's why you start 1 above. Our period's pretty small too, so I decided to draw 2 periods. And this is what our secant graph looks like. Okay. All right, and then number 4 is a cosecant. So go ahead and pause if you guys want to practice this one, and I will be back with the key. All right, and then this one was back to a sine. Full period is 2 pi. So you should see 2 parabolas and 1 full period. This one was off the graph, yes, I know, but I just still drew it because there was room to. And it's nice to see it. So yeah, so that's it for secant and cosecant. So I hope you didn't find that too difficult. Let's go ahead and discuss some homework. So for homework, you're going to be doing RSG 6.8, which in that part 2 packet is on pages 8 through 10. And you're going to be doing numbers 1 through 6. All of them. The key will have everything, which I believe is 1 through 8, if I remember correctly, but you're only required to do 1 through 6. Okay. Have a good day, guys.